Hello, I hope you can hear me. My name is Professor Jonathan Corney. I'm a member of the academic staff in the Department of Design, Manufacture and Engineering Management. I'm going to take about 25 minutes to give you an overview of two of our MSc courses, the MSc in Advanced Manufacturing Technology and Systems and the MSc in Mechatronics and Automation. So I'm going to give you a very brief overview, a little about the university, the department, because the context of these courses is important, and then some of the detail of the subjects and the structure of the two MScs. It will be possible to ask questions at the end, so please stay online and either verbally or by chat, if you've got questions or things that occur to you as I'm speaking, please save them for the end, and we'll be delighted to talk about those. So, the place to start, I think, for those who aren't familiar with Strathclyde, is to explain that though the university was formed back in the 17th century, 1796, during the Scottish Enlightenment, and has always had the motto of being the place of useful learning, much of the campus has been renewed. We're in the centre of the city of Glasgow, one block away from the main square, so very vibrant urban environment. But there's been a tremendous amount of building and renewal over the last few years. And you can see from these pictures that many of our buildings don't look 17th century. We've got new facilities which benefit both from the location and the history of the university. As I said, from the very beginning, from the founding fathers of the university, their motto was that it was going to be a place of useful learning. So the emphasis was never on history or sociology. The emphasis has always been on the sciences and engineering. Today, the university is distinctive for its engagement with industry. So though we have academic researchers who are looking at the fundamentals, we also do a tremendous amount of collaborative knowledge exchange and research supported by engineering and technical companies, big and small. And you will see as I talk through the presentation that some of our collaborators are world famous on the scale of Boeing or Rolls-Royce, and others are small startups that are local to the university that will one day be as big as Boeing, I'm sure. So in the National League tables of UK universities, we have been ranked very highly for our equipment and facilities. I think we were third in the UK, third best for the scale of our laboratories and facilities. And we will see a few pictures as I talk through, and you'll quickly understand why we got that ranking. So the department that runs the two MScs is one department in the Faculty of Engineering that contains electrical, mechanical, civil, chemical engineering departments. But our department has a more unusual name. We're called the Department of Design, Manufacture and Engineering Management. We're an industrial engineering department, though that name isn't common in the UK. So in North America and China and India, I think you find many industrial engineering departments which combine the teaching of design, teaching of manufacture and engineering management in one place. In many academic institutions, you might find design being taught in the art college, engineering, design and manufacturing being taught in a mechanical engineering department, and manufacturing, if it's taught at all, being a sub-discipline of, say, mechanical again. But for historical reasons at Strathclyde, it's always been in one department. And this gives us a unique perspective. We can understand how all these subjects, which can't occur in isolation, are taught, have to be understood as a whole rather than in isolation. So Our facilities, as I said, are second to none. And on the campus, you can find the laboratories and manufacturing and automation facilities that you would expect. Many of these are on open access to the students, and they're all supported by technicians who are experts in the use of the equipment or the software. I won't dwell on these, but what I want to do is make it clear how research links to teaching. And you can see that in this picture that we've got great 3D printing and rapid prototyping facilities. You're only seeing a fraction, at the tip of the iceberg on campus. Another part of the department, located a few miles away, close to the airport, is a research facility called the Advanced Forming Research Center that today employs almost 100 people. Has had many tens of millions of pounds invested in it, and is dedicated to researching the forming of metal for high-tech applications. And as a student, you might think, well, I'm coming to learn, I'm not going to do research. But it's precisely this scale of activity that allows us to provide the facilities for the students. So research pays for much of the equipment, research pays for many of the PhD students and the researchers who support some of the classes. It provides opportunities for the students to work with industry that wouldn't occur if we weren't so research active. The Forming Research Centre, for instance, has many, I would say, exotic forming processes that are unusual, that you wouldn't find in a normal manufacturing facility. And these have been paid for by companies like Rolls-Royce and Boeing and Tymet and Metis Aerospace, because it allows them to experiment with more effective ways of making their components. So whether it's full-scale superplastic forming, whether it's flow forming, or rotary forging, the AFRC, the Forming Research Centre, has industrial scale facilities. And the link between that and design is easy to see when you look at a process chain of how techniques like rotary forging and flow forming can be linked together to allow you to deliver exciting, attractive designs at a lower price. And of course, that can only be done with good engineering management. And so though at first glance, maybe some of the manufacturing research looks deeply technical and focused very specifically on particular metals and particular components, we, because of our nature as a department, are always aware of how these processes fit in to the big picture. We're always thinking about the overall impact on design and manufacture. We're thinking about the process chain. We're thinking about the supply chain. This facility, as I said, is a couple of miles from campus, and the students have contact with it through the opportunities for projects and the access to equipment that it provides. On campus, we have 6 or 7 research groups within our building. I'll only mention one that's of particular relevance to these MSCs, the Centre for Precision Manufacturing. It's led by 3 academics who have 2 tutors and almost 35 researchers, a mixture of PhD students, EngDs, and visiting scholars. And their focus is on the precision forming of ultra smooth materials and very small components, micro and nano components. So if you're imagining small mechanical sensors or optical systems, perhaps lenses or mirrors, These are the sort of components that this group is focused on. And because of their international reputation, they're able to attract funding for PhDs and NGDs. And you can see the visiting scholars is also evidence of how well respected they are. As students, we benefit not only by having lectures from people who are at the forefront, but also access to equipment that's been paid for by their many research activities. So I think when you're choosing a university for postgraduate study, you should always investigate the levels of research that go on, because really teaching alone can only provide very basic equipment. To provide the state-of-the-art facilities that we have, you need to be doing a lot of research to generate the money. So hopefully that's painted a broad picture of the university. It's given you an overview of our campus, very quickly of our faculty, and you have at least a flavour of the department. I'm now going to talk about two of our MScs. We have a portfolio of MScs, some in the areas of engineering management, some more focused on design, but two that are particularly relevant to the manufacturing and automation technologies are these: the Advanced Manufacturing Technology and Systems, MSc, and the Mechatronics and Automation. You'll see underneath that, though I've talked about them as MScs, it says leading to a PG DIP or a PG Cert. So let me just explain what they mean. And in doing that, I have to explain about our language of credits. So every time you do a class in the university, you're awarded so many credits. Credits vary between perhaps 10 for a single semester class, or 20 for a double semester, or a class in a single semester that's got twice as much lecturing, up to larger credits of 60 and 80 for research projects and theses. So all the MScs have the ability to award qualifications with different numbers of credits. Sometimes this is useful to people who only have a limited amount of time or money, and allows them to do a course, a partial course. Other times it provides people, acknowledges that their achievements when their circumstances change. If illness or family circumstances change and they have to leave halfway through the course, it gives them a way of acknowledging the achievements that they've had in the time available. So a certificate, a postgraduate certificate, you've got to amass 60 credits in the taught classes. And a postgraduate diploma, twice as much, 120 credits in the taught modules. Usually, very roughly, you could say the certificate is won after one semester and the postgraduate diploma after 2 semesters. But of course, what we hope, and what the vast majority, over 90% of the students, do is stay on to do the whole MSc, where they do the taught classes in the first 2 semesters, and then a research dissertation in the 3rd semester over the summer. So I'll tell you the structure of the Advanced Manufacturing Technology and Systems MSc. And you'll see that it's broken down into 4 elements. You've got core classes, which are worth a total of 50 credits, and these are the compulsory classes. You have no choice. If you're doing Advanced Manufacturing Technology and Systems, you have to do these core classes. Then there are elective classes, so you can choose which ones you do, and I'll show you the list in a minute. And then everybody has to do a group project. It's an industrial group project. So the students are allocated into groups of 4 and assigned a collaborating company or enterprise who have a project for the students to do. This is both it's exciting to work on something that has real practical benefit to the companies providing the projects, but it can also be quite stressful because the companies full of steely-eyed people in suits who expect deadlines to be met and timescales to be realistic when they're told the plans. So there's a considerable amount of stress involved, but it does give all the students something to put on their CV about working on a real project for a real company. And these projects can range from factory layout optimization to automation projects for specific elements of an existing process to design that companies have new products and they're trying to get some focused effort on some aspect of that. After the industrial group projects are finished, then there's the summer research dissertation, the MSc dissertation, which is worth 60 credits. You'll see from the breakdown of credits that were needed for the certificate and the diploma that you can achieve these with the taught classes. So what isn't shown on this diagram is that you can't go on to do the MSc dissertation unless you have sufficient credits to get to be able to obtain the MSc with a satisfactory dissertation. So you have to have 120 credits at the end of your taught classes and the industrial group projects to proceed. So there is a bar, a threshold that all the students have to make before they progress on to the MSc dissertation. There is opportunity you don't have to pass everything. You can get an MSc if you fail one class, and you can get a postgraduate diploma if you fail 2 classes. The vast majority of people pass everything and pass it very well, so then they can have an MSc with merit or distinction, depending on their final marks. I guess of specific interest is, what are the core classes and what are the electives? Well, the core classes for the Advanced Manufacturing Technology and Systems, MSc, are shown here. So they range from classes like Advanced Forming Technology and Advanced Materials and Production Technology, from classes that are focused very much on the technologies of manufacturing. These are classes that are looking at different processes, whether it's forging or forming machines or additive layer systems. They're giving the students an overview of the technologies that are currently used in industry, their limitations, their strengths, their relative costs, their capabilities. Micro and nano manufacture builds on the strength of some of our research groups to introduce the manufacturing of precision components. We saw in that example of one of the research groups. So this is really high value exotic manufacture of things like sensors and optical components, waveguides that have to be produced with tolerances and dimensional accuracy far exceeding the levels that you find in normal engineering components. Manufacturing automation is not just robots. The robots obviously play a larger part of it. It's also looking at controllers for handling and delivering components around the factory. So whether that's an unmanned vehicle or a conveyor belt being controlled with a simple microcontroller or a programmable logic box, the course gives you an overview of these and some experience of how they're programmed. And strategic technology management is not technical, but is taking a step back, looking to see the wood for the trees, and how do you integrate these processes and developing technologies together to create a business. Those are the classes you have to do. Perhaps students spend more time pondering which of their electives to do on the manufacturing MSc. So you have to choose 3 of the following. So the list is longer, and I think the choice is difficult because they're all interesting. System thinking and modeling provides you with tools for, again, standing back and seeing the wood for the trees and understanding not just how individual technologies and processes perform, but how they join up to form a network or a system. Constantly gets good reviews from the students who do it. I think it's a very thought-provoking, very different sort of subject. If you've come from a technical background, it's a stimulating thing to do. Sustainable product design and manufacturing is introducing ideas of circular economy and remanufacturing to the students, explaining how these can provide not just environmental benefits, but economic and social benefits. And again, it's introducing concepts that are new to many, but build on research strengths of the university. Strategic supply chain management is looking at how you optimize the flow of goods, not just within a factory, but between a chain of production. Where people are making components and shipping them to somewhere else to be finished, and then maybe another place to be assembled into a final product. Fundamentals of Lean Six Sigma, very popular course, especially with people who are doing the course part-time, who are working for industry and doing the MSc over 2 years, because this provides you with, if you like, statistical tools for improving processes. So within a working environment, there are many things that are slow or bottleneck processes. And sometimes it's difficult to identify what the problems are or to explain to colleagues what needs to change. And Lean Six Sigma provides those tools for effectively doing experiments on systems where you can measure performance of people and things and demonstrate how much variance there is and when this is causing problems. Mechatronic system design techniques is, we talked about automation, not just being robots. Of course, the technologies within robots, the motors and the controllers and the sensors can be employed in many devices and many manufacturing systems. So the Mechatronic module gives the opportunity to learn more about those and how they can be integrated into manufacturing systems. Design of experiments for process optimization is another class that introduces statistical tools. The difference from the Lean Six Sigma class is that this focuses more on what's called the DOE method, when you have numerous variables. How can you choose? Let's say if you know a process depends on 5 or 6 things, how can you find out which is the most important thing, which are the 2 most important things to control? And there are formal methods for assessing the influence of different parameters on outputs with the minimum number of experiments. It sounds, perhaps I've explained it clumsily, but it's very elegant and surprisingly simple. And the students have an opportunity not only to learn the theory, but to see some of the practice. And then finally, there's project management. Perhaps for many engineers, that wouldn't be an exciting module to do, but it is a very sellable class to have experience of if you're looking for jobs in industry. Eventually, all successful engineers end up as project managers, and many of them are self-taught. So the opportunity to do a project management course and actually learn the tools and techniques is one that many people wish they could go back in time and do in later life. So I hope that's given you an overview of the manufacturing course. We'll turn now to the Mechatronics and Automation course. And you can see that it's got very similar structure to the manufacturing course. We've got a core of classes for which you get 50 credits if you pass them all. It's got a number of elective classes for 30 credits, and then followed by an industrial group project that everybody does, and an MSc dissertation. As I said earlier, the group project is popular because it gives contact with industry, and sometimes stressful because of that contact with industry. But also, the other thing the students are learning from their group projects, of course, is managing the dynamics of the group. So it's not just a technical challenge of carrying out the work, or the managerial challenge of interfacing with people outside the university in a professional manner, but also the management of one's colleagues. But this is what real life is like. If we look at the core classes for the Mechatronics and Automation class, we can see that it has different core classes from the manufacturing ones. So these are the compulsory classes that you have to do if you're doing Mechatronics and Automation. Not surprisingly, got a manufacturing automation class is one of the core ones. Mechatronic system design techniques, that you'll remember was an option for the manufacturing class, is compulsory for this one. Product modeling and visualization, project management, and engineering risk management are all compulsory for the Mechatronics course. The list of electives for the Mechatronics Automation course is slightly smaller. You've got to choose 3 from 4. Again, the systems thinking, robotic systems and control, I think delivered by colleagues in the electrical engineering department. Control principles and design methods allow you to get to the core technologies of automated systems, and also understand how large teams of people can collaborate in the design of mechatronic systems. Mechatronic systems are not like you can't design them with the same process that you use for, let's say, a mechanical component. They're too sensitive to change, there are too many interactions. But models and methodologies have appeared that allow groups of people to successfully collaborate on the design of mechatronic systems, and design methods will give you some insight into those. Both classes have the industrial group project that I've mentioned a couple of times, talking through it. I think the headline features of that is that we run nearly 70 industrial group projects with our final year undergraduates and MSc students from all our MScs. We have a presentation day when the companies and the students, the companies who are sponsoring and supporting these projects, come to the university, and there's a day of talks and displays of the work that's been done. So the students are not only getting first-hand contact with industry, but also getting experience of public presentation and presentation to large audiences. We're able to do this because previous years have been so successful. I think every year, 1 or 2 of the projects presented to the 1 or 2 of the projects that have been part of the industrial group projects go on to become real products or are really implemented in a workplace. And because of that, the collaborating companies return year after year to run new projects. So this year I'm supervising two industrial group projects. One is with a gin distillery who are looking to automate the waxing of the gin bottles at the end of the process. And the other is with a manufacturer of large valves for nuclear power stations who wants to incorporate a different way of sealing. In both cases, students have had to understand the current process and research the possible solutions, present those solutions to the collaborators, and then detail not just the technical feasibility, but also the costs and justification of their proposed solutions. So very different industries. You know, the gin distillery is really a production line with in the far north of Scotland. The manufacture of valves is a heavy industrial environment in central Scotland, but a great experience for everybody. The vast majority of students pass sufficient exams, get sufficient credits to go on and do their dissertation. The dissertations, the topics are allocated very early on in your MSc year. So often in October, the students will have been able to select from a list what their MSc topics are going to be. The list is populated with suggestions from members of staff, and obviously it's often informed by the research strengths of the individual groups and members of staff. By January, they should be able to produce a project proposal, a couple of pages explaining what the scope of the project is, what's included and what isn't included, what the aims and objectives are. In May, they should have a justification of the approach they're going to use to achieve those aims and objectives. And then the main effort, the real work, starts in May after the last of the taught classes have finished and goes on through to August. So the thing to appreciate, I think, about an MSc, if you've done an undergraduate degree, is that an MSc really is a year. It really isn't just a couple of semesters of teaching and then a summer holiday. This is a full year running from September through to August, with the students constantly engaged. So it's an intensive year. And then the MSc dissertation has to be submitted in early September. One thing we're proud of our MScs, and again, a distinctive thing about the Strathclyde MScs, is that they are accredited by the engineering institutions. So both these MScs are accredited by the Institution of Engineering Technology, the Electrical Engineers, the Institution of Mechanical Engineers, and the Institution of Engineering Designers. It allows you to apply for membership of these institutions, if that's useful to you, for progressing your career. I think it also provides an external check on the quality. So these accreditations aren't given out lightly. These engineering institutions have visited the university, they've looked at the syllabuses, they've looked at the exams, they've looked at the assessments, and they've said that these are appropriate for professional engineers to join their institutions. So I would always look, if I was selecting an MSc with an idea to progress a career, I would always look for its professional accreditation. You may not, in the end, join the Institute of Mechanical Engineers or the IET or the IED, but having done this, you'll have the option. And if you do join, it provides you with a network of contacts and industrial access that you wouldn't have otherwise. So a lot of the we haven't seen many students during this presentation, but we've seen even less. So one of the things that provides makes all the difference on an MSc is the quality of the people teaching it, and we have here's a brief overview, a few names that you can Google to investigate the background of the staff involved, and hopefully you'll be impressed, not by their youth. And finally, what the students do with this, some of them do exactly what it says on the title of their degree. Some of them go off and become manufacturing engineers. Some of them become automation engineers and install automated systems or design automated systems around the world. Others take their qualifications and work in industries that are connected but perhaps not directly related, and others create their own companies. So a good way of getting an overview of all the different things that people do is to look on the DMEM Facebook page. Please join our Facebook page, and you'll see there's a constant stream of news and updates about events in the department, the university, about achievements of present students, of former students, of events. I think within a few weeks you'll have a good impression of what it's like to be a student in DMEM at Strathclyde University. So I think that was very fast. Hopefully not too fast. I haven't you've been able to keep up, but we'll switch the microphones on, and hopefully some of you have maybe thought of some questions, or there's some things I said that you'd like to get more clarification on. So. Hi, so if you've got a question, you could instant message would perhaps be the easiest way. So if you want to type something into the chat box, everyone will be able to see your question, and we can answer. Okay, so I'll switch my microphone off just to stop the feedback, but we're watching the chat box and we'll reply if there's any questions.